And first off, just want to give a bit of love to various people who I've been specifically inspired by. I mean, there's loads of great speakers in this series, but Marilyn Manns for particularly for Fearless Change, Suzanne Kaiser for her amazing work combining team topologies and domain-driven design and wording mapping, Steve P for his work on flow engineering and a whole bunch of other things, and more recently Amy Cates and Bill Carberry. But like I've been inspired by many of the people in this conference series, and some of the ideas from there will emerge in the material I'm sharing. So I'm Matthew Skelton. My focus is on holistic innovation. I'm the originator of the Adapt Together approach from Conflux, and I'm the co-author of the book Team Topologies. You'll find me online at matthewskelton.com. Here's the proposition. It looks pretty much like this. Small, scrappy startups that use generative AI will be able to out-innovate larger incumbents, at least initially. So, what would an effective kind of AI-savvy or AI-aware operating model look like that used AI to reduce time to value for larger organizations? Scrappy startups can always move really, really quickly, right? So some of the challenges that emerge from being very small are just not there. They just don't see the kind of challenges that are there in large organizations because of communication pathways and all of the stuff that we know about. So we primarily work in large organizations, and we're really thinking through what does it look like in terms of operating model. Can we skip ahead to an AI infused or AI savvy operating model that helps these organizations kind of navigate in the marketplace, in the world, and achieve some degree of agility? That's the question. And I think so I'm going to give the answer away straight away. Basically, I think we already know. I think we already know what this looks like. And I think it looks like this. I think it looks like empowered teams, no handoffs, ongoing stewardship of services, clear boundaries, and active diffusion of knowledge across the organization. Now, I'll unpack this as I go through the talk, but these are the things that time and time again organizations have effectively proven out as a way to achieve business agility. This is prior to generative AI, but I personally think that generative AI doesn't change things as much as people do, or rather it changes things massively, but not necessarily in the way that some people are talking about it. Let's see. We'll talk about these things. We'll look a little bit about the kind of a possible AI advantage in the near future. Maybe it's here now for some people. I'll just give you a little bit of perspective or a little bit of detail about my perspective on AI and sort of work in general, because I think it's kind of relevant. And then I want to explore a little bit about how we trust and organize AI, which I think is super important for for thinking through this whole problem. And then finally, we kind of wrap up towards what does this operating model start to look like. So let's unpack this whole thing about AI savvy. When we say savvy, what we mean is like a good understanding of what we mean by AI and how it's used and what its properties are and that kind of thing, so that we're not sort of misusing it, or we're not trying to use AI in ways which are just not suitable. You could characterize AI like this. We've got traditional AI, which is kind of machine learning and that side of things, kind of the big data stuff, and that's all about pattern matching and huge data volumes and temporal correlation, a bunch of other things. There's different ways to characterize it, but that's how I'm going to characterize it for today. Then you've got generative AI, which is kind of built on that to some extent. We're effectively guessing the next token in the sequence. We're generating content. We're generating options for other people or other agents to assess. I mean, there are different ways to characterize different flavors of AI, but that's what we use today. The key thing here in machine learning and AI and so on in general, there's talk about learning, and there's a specific kind of learning that happens, or an activity that happens inside the neural networks that underpin all the AI stuff, and it's called learning, but it's devoid of understanding. There's no actual understanding there yet. We don't have AI systems which are more like general intelligence. There's ability to predict based on kind of past data that's already been seen. But I think part of being savvy in this space, part of being aware and switched on in this space is let's not pretend or forget that AI, we shouldn't pretend or forget that AI does not understand. That's what we're going to be. We're going to be savvy if we don't pretend or forget that AI doesn't understand. Because then we can use it in a way which is actually really, really valuable, really suitable. So we can speed up content generation, whether it's articles or videos or a bunch of other things. We can also speed up code generation. I don't actually think that code is content, but that's how some people see it. And for certain kind of things, it's a bit halfway between content and something else. But certainly speeding up existing things is part of the picture. We can speed up entire workflows. Fine. So we're just making things shorter. That doesn't necessarily actually increase our business agility at all. It doesn't necessarily give us any better business outcomes, because if we're not dealing with the bottleneck in the workflow, then all we're doing is creating more inventory, more piling up of stuff, which then has to be kind of dealt with later. There's a load of kind of handoffs or queues in place. So we're not necessarily solving the end-to-end kind of value flow. But there's some value. There's potentially some value here and there in speeding up generation of things like content. Things that can be predicted based on the current word, what's the next word or kind of token likely to be. There's clearly a savvy use case for AI around augmenting human decision making and options. That's been the case for a long time. So expert systems from the 1970s, 80s, 90s certainly, where they've got these expert systems have got a very focused kind of domain context. Things like medical augmentation of kind of medical decision making for things like detecting cancer and things like that. That's been proven out for quite a while. But also just kind of options. So given the vast array of data that's behind these AI systems, can we recombine that in ways which it would just take forever for humans to do? And we'll come to this a little bit later. Recombining all these different options, going, ta-da, look, we've got like 5,000 different options, and then we can use other methods to kind of test these different options way more quickly. In the obvious cases, things like protein folding or drug discovery, where we're able to run through like many combinations way more quickly, produce a subset for, I don't know, humans or scientists or someone else to select and work with and go, oh, that's really interesting. I never thought of that, never thought to look at that kind of, I don't know, protein folding or that kind of product option or that kind of way of combining text in that form. That's kind of, it feels novel. It still is a recombination of stuff from before, but it kind of feels novel. Okay, that's actually saved us a lot of time because we kind of wouldn't have thought to combine things like that. And that's brilliant. Let's go and try that. And it turns out that that's a viable candidate for drugs or for content or something else. And of course, there's something beyond that, which is more like agent-based processes. So can we create an agent which has a sufficiently kind of rich ability to respond to input and then go and make some so-called decisions by itself, even to go off and create additional services in software and communicate to other agents. And we've seen just this week a protocol released from one of the big AI companies that helps to have kind of multi-agent communication and things like this. So we're seeing some of this stuff solidify now that allows this stuff to scale better rather than just like individual humans typing into ChatGPT. There's kind of more of like an industrialization of the landscape. So these are all kind of really just kind of switched on sensible uses for AI. It's a bit difficult to try and work out what the future looks like clearly, but we don't even need to do that because get this, we can actually act like an AI and just look backwards at what's gone before, which is what AIs do, right? They're just looking at the previous data. So let's look backwards instead of trying to gaze into the crystal ball and see what happened at the most recent big disruption certainly in the kind of IT space recently, and what happened. So cloud was arguably the big disruption in the IT space. starting from when about 2007, 2008, arguably with Amazon EC2 as the first kind of like, run your server in the cloud offering. Now, cloud gave birth to software as a service. That just didn't exist before. An entirely new business model, which is extremely profitable and massively disruptive. So we're working with, let me see, 4, maybe 5 organizations at the moment that are all struggling still with the fact that their business model from the early 2000s was massively disrupted by SaaS, which came in, like 2008. Now, clearly in different sectors, SaaS has taken longer to reach, but organizations are still kind of didn't see the benefit, didn't see the opportunity in SaaS in time, and didn't take the time to kind of change what they're doing. One particular organization, for example, that we worked with, they were the leaders in their field, but their software was desktop software, so Windows desktop software. And it worked really, really well. They had the biggest market share and the leaders in the field and so on. And they just sat on that lead, that market lead, and didn't do anything. No re-architecting, no investigation of cloud. And it got to a few years ago when we were working with them, and the situation is effectively desperate because all of their competitors are moving way ahead. The organization hadn't invested at all in this new capability. In this case, it was cloud. And so they were really, really struggling because they couldn't scale the software, they couldn't scale their product. And the people in the field who were using this thing were like, I can't run it on a laptop. That doesn't make any sense. It needs to be in the cloud. And so the organization has sort of missed the importance of this big technology change in terms of their actual kind of profit viability as a business in this space. So, I mean, the work we were doing was to help them shift into the cloud. But clearly, Gen AI is going to introduce a new kind of business model, or maybe more than one. We can't necessarily know exactly what that looks like yet, but almost certainly it's going to be something new. And so in organizations that have the agility to be able to adapt to that kind of new model are the ones that are going to then succeed, rather than be left behind. The promise of agent-based or agentic AI is something like this. It can go off and devise like 230 new product variations, and it can generate the code, it can deploy it into production, it can test with some synthetic users that behave in a particular way or that have particular goals. It can try and find the best combination of features and stuff, data, presentation, whatever that works. So effectively, we've got a data-driven product fit. We've done that in the space of hours, not in the space of days, weeks, or months, which it normally takes. So just as cloud removed infrastructure, like IT infrastructure, as the bottleneck. Before cloud, it would take months to provision infrastructure. So cloud comes along and suddenly you can spin up servers in the cloud in seconds or minutes. It's reduced that bottleneck. So we can do things way more quickly, and that SaaS can be born partly because of that. In terms of Gen AI, we can then test out a huge number of things very, very quickly. We're generating the ideas. It's potentially generating product ideas. It's generating the code alongside it. It's actually doing the testing and reporting back. Suddenly, product managers have an amazing new capability, potentially. Stuff which would be very expensive and potentially error-prone, now potentially is very cheap. We could even throw away most of the code that was generated for those 230 product options. Maybe we throw away the code for 225 because we're never going to use it again. And we just retain the code for the ones that actually work. So there's different ways of thinking about what we're producing as we're working in this kind of space too. It's like A/B testing on steroids, effectively. So it sounds amazing, right? And I think there's something in that space which is already happening, but that's the kind of promise. We're able to kind of work in a sort of a new way, or rather it's extremely speeded up. Like time to value is extremely shortened. So then we can do different things. We can spend our money in different ways. Rather than on having to bet on a particular thing there, we can actually, we've got greater certainty about a particular approach in certain cases. However, clearly, it's not all roses, right? It's not all sweetness. Maybe large language models are approaching their limits. We've seen that in the last few weeks or months. And there's some interesting reasons for that if you think about the nature of information architecture, like something that has a very, very huge corpus of context or awareness and knowledge, so-called awareness and knowledge. How feasible is it for that thing to actually give a high fidelity response to a particular specific topic or domain or business context? It's so from my understanding, that is kind of not particularly likely, and so we'll have a look a little bit later. There's evidence that smaller, more focused models, a bit like the expert systems that have been around for decades, smaller, more focused models actually perform way better, and that then focusing down the domain coverage or the context can help with various things, and we'll see that a little later on. There's some really serious security problems present in this tooling. There's going to need to be a whole suite of tools, approaches, new roles, new jobs, thinking about and dealing with security problems in generative AI. Because the scope of generative AI is way bigger than it was before. Back in the 1990s and 2000s, we had a lot of fun with something called SQL injection, which is where people would try to squirt in like malicious commands into web forms in order to kind of hack into a database. That looks like a walk in the park compared to the security problems that you can get with generative AI. And there's things like this. There's a typical workflow inside AI or machine learning applications that looks something like, well, the data scientists do something, and then they pass it to the data engineers, and the data engineers then do some more stuff, and then they pass it to the machine learning operations people, and there's these handoffs. And these are quite common, and there's sort of good reasons, if you like, for it. But this is the state of play in the IT application software development space back in about 2010. And it was really painful. And we've solved these problems. Back in 2013, I published a set of patterns called the DevOps Topologies patterns, which became really well known, used by organizations like Netflix and Condé Nast and consultancies like Accenture and all kind of different organizations around the world. The patterns in here and the thinking behind it then became the kind of the seed for what later became my book, Team Topologies. And what's happening is that in that machine learning ML space, they're effectively just repeating the same patterns that we've already solved in the kind of IT software application space. Already solved, or rather, loads of organizations are still going through this process. But the point is that the ideas are being kind of talked about and discovered and accepted as being like obvious for what's that now? They're 10 years at least in the IT application space, but it's still relatively new inside the machine learning AI type space. So lots of organizations are basically going to speed run the same problems that the whole DevOps movement was there trying to solve from about 15 years ago. Okay, I'm going to run through very, very quickly. Like, why should I be talking about this stuff? Like, what's my perspective on AI and work in general? So I built my first AI system in 1998. Technically speaking, it's a back propagation neural network. It was at university. It didn't really work very well, but that's kind of my earliest experience with that. So it goes back a little way. I was actually taught on that particular course by this person here, Professor Mark Bishop, who is the Professor Emeritus of Cognitive Computing at Goldsmiths, University of London, and is now a scientific advisor on cognitive systems to Fact 360, which is an organization in the UK that's doing some really cool stuff with like AI and machine learning and risk and cyber risk and so on and so on. So like from a quite early time, my involvement in this was from someone and other people in the university who were very switched on about like cognitive computing and AI and so on. I did a master's course in the University of Oxford about neuroscience, so brain science. I did some research into dyslexia and Alzheimer's disease. 2001, I built software for brain imaging machines. Again, I'm kind of aware of like some of the aspects of like how cognition actually works. A little bit later, 2011, I was doing organizational architecture and new techniques and tools for adopting cloud and continuous delivery at a company called Trainline that's based in the UK, selling an organization that retails train tickets for most of the UK train network and now into Europe as well. And it was partly based on some experience there that I did this blog post in 2013, thinking about different ways in which teams can interact in the context of having to go quickly. That then became the DevOps topologies, like I mentioned before. So I've been in this kind of space thinking about being aware of kind of like what you might call AI, or at least neural network based sort of cognitive systems like this. And I've been thinking about organizational capabilities and how it works together for quite a long time. All of this stuff came together into the Team Topologies book, which was published in September 2019. That's just over 5 years ago now. And it sold 170,000 copies worldwide, which for a business book is pretty good. So we're super grateful to all the people. Many of you on the call now will have bought it and seen it and recommended it and so on. We deliberately tried to write it in a way which is very accessible to practitioners and to leaders and managers. I think we succeeded there. We really tried to ground it in some of these core principles that we're looking at today. It's been used in all kind of different parts of the world as well, different kinds of organizations building different kind of software and even beyond software. It's been used in legal, to run legal services. It's been used to run doctors' practices in the UK. It's been used to think through how to change higher education courses and a bunch of other domains as well, accounting and so on and so on. It's not just about delivering software. But the learning for me from all this is that delivering at speed means we need to organize for fast flow in a kind of socio-technical sense, bringing together, thinking about the combined. We can't separate the technology from the people part. We're bringing that together and thinking about it holistically at the same time. And I still think this is what we need to do in the context of AI. Fundamentally, I don't think the challenge is any different, really. Some things look different on the outside, but I think the underlying dynamics are basically the same. So how can we trust and organize AI? Let's assume that we've got a collection of AI agents. So these are autonomous or somewhat autonomous AI systems. They've got some kind of input and they're doing some work. And they're responding to some kind of input from humans. Now, there's a realization that I had, I think it was yesterday or the day before. If you've used something like ChatGPT or Claude or something like this, you're typing commands into the text box, and there's this phrase that's kind of, or this description of that activity that's appeared called prompt engineering. Effectively, we're trying different ways to prompt this machine to give us the output that we want. And we have to kind of craft the prompt in a particular way. We have to say, don't do this, assume that you're a leader, assume that you're a civil servant, whatever it is that you're trying to do. And we're trying to engineer a prompt that gives us the output that we want. So that's kind of prompt engineering. The realization I had was that from the perspective of many executives, so executives in organizations, C-suite, CEO, CFO, COO, whatever. From their perspective, trying to craft the right kind of prompt into a ChatGPT or a Claude or whatever, trying to engineer the right prompt into a Gen AI tool doesn't feel very different from trying to generate the right prompt into the IT department to tell them to build systems. Because it all just feels voodoo. It feels magic. It just feels like, well, there's a black box. I don't really know how to make this thing work. Give me the right output. So yeah, we have to do all this engineering with ChatGPT. It's the same thing from their experience. In many organizations working with IT departments, they have to kind of ask questions in different ways. And at some point, something will pop out at the end. Is it what they want? Is it what they had in mind? Often not. Because there's such a disconnect between the intent or the stated intent of the organization, kind of in terms of strategy, in terms of direction, where they want to go, such a disconnect between that strategy and intent and how that gets translated into, let's say, software. So lots of organizations have tried to get better at kind of prompt engineering for humans, the traditional IT or engineering department, like trying different techniques, like better specifications or more project management or program managers, a bunch of other things like this, and it still doesn't really seem to give the results that we want. Clearly, the organizations that are doing really well in this space are the ones that have empowered the teams building the things to have better conversations with the people who have got the ideas and the intent. And guess what? In those organizations where there's more joined upness between those two parts of the organization, the outcomes are way better. But the organizations, but yeah, that's a bit of an aside. But just as a mental model, a lot of execs don't see much, I think, difference between like a ChatGPT and the engineering department, because it's kind of like put in some kind of gobbledygook and maybe we'll get something out at the end. Which is the sad state of affairs, but that's I think a realistic assessment of where we are. So let's just assume in the future you're working in an organization and there's this collection of AI agents, they're running somewhere, either on premise, in the cloud, doesn't really matter. And they're responding to some kind of input from humans. We've got some organizational intent, and humans are somehow putting some kind of message into these AI agents to get them to do some work. That's the point of having them in the first place. So again, just like before, if we're going to be savvy about this, switched on, don't pretend or forget that AI doesn't understand. AI is not understanding, so we can't give it stuff where understanding is needed. So in this sense here, then, we're expecting humans to set the context and goals and guardrails and execution constraints in a repeatable and traceable way. Guess what? That's called programming. That's called programming. The actual programming language that we're using might not look like Java or Python or any of the current languages from today and the past. But setting context, goals, guardrails, execution constraints in a way that's repeatable and traceable, which we'll need for audit trails and the regulator and so on. This is effectively a kind of programming. So humans will still be programming these systems, but the nature of that programming will look different compared to what it looks like today. So humans are setting all this context and constraint and so on. How are we then able to trust this set of AI agents? Because are we going to leave them to go and do various things? Like, what kind of freedoms do they have? What kind of constraints are we got to put in place? If we're going to navigate this kind of challenge, which I think we'll need to, and organizations already are navigating this, let's just step back. Like, how are we able to trust a set of people? So in the organizations that do this well, we put in place guardrails, an ongoing domain context for that team of humans. We put in place good boundaries, and we put in place ongoing stewardship and responsibility. And that's how we can trust them, because we've aligned the incentives effectively. And we can then have trust that they are going to do the right thing for that particular outcome that we're trying to drive. And so I think then we're blending these two together. We end up with teams of humans and AI agents with the right context, guardrails, stewardship, boundaries, and so on. It's kind of the same thing. And it's important to note that boundaries are going to be needed for these AI agents because, like I said before, with a context window that's too large, whether it's for a human or an AI agent, an amount of context that's too big results in poor design. It results in difficulty in execution. In the case of humans, it increases cognitive load too high. In the case of generative AI, it seems to result in, if you have a large context kind of area, it seems to result in poorer outcomes. So we need to shrink down the amount of context to be right size, whatever the right size is. Good boundaries are also good for security. We're better able to reason about what we're talking about. And actually, it turns out that there's a strong link between domain fidelity, so our ability to have high fidelity understanding about the domain we're working in. There's a strong link between domain fidelity and security. So a lack of domain understanding and fidelity typically results in a lack of security. There's actually a book on my desk somewhere which talks about this. I'm going to recommend it right now. I forgot about this. But let's do it. This book here, Secure by Design, I'll put it on the video. Secure by Design is by three people called Dan. There's Dan, Daniel, and Daniel, and the fourth is by someone else called Daniel. There's four Dans involved altogether. Anyway, it's a great book, Secure by Design, and it really goes through that that link between domain fidelity and security. So it's there for humans because we're talking about effectively knowledge work. We're representing concepts in code. It's going to need to be there for generative AI as well, AI agents. We're going to need to have some security boundary. We can't just let an agent go off and like touch any kind of system in the company because we're not able to reason about the effects properly. So my prediction, this is a dangerous this is this dangerous point where this is a prediction. I think some organizations will not take the learnings from like IT over the last 30 years, not take the learnings around kind of restricting domain context and setting boundaries. They'll end up with AI agents kind of being able to touch everything, and they'll realize, ooh, that was a bad idea. We need to put some boundaries in. Boundaries are useful as well for resilience. So this particular system here there's a problem with it. We actually need to shut it down. Let's just shut down that particular part of the system, and then we can replace it or fix it or what have you. But the rest of the system doesn't fall over because we built it in a resilient way that has got good boundaries in place. I think this is relatively well understood in terms of kind of software architecture, but there still seems to be a debate in some places about the importance or lack of importance of good boundaries in design. So I think these things, there's a need for like a right sizing of context for both humans and generative AI. There's a right sizing of and there's a need for boundaries in place and that help with security and resilience. And so all of this, to my mind, now that clearly I'm kind of biased, right? I wrote a book which I was very pleased to write, and I'm looking for where the ideas fall down, but generally speaking, I think there's a lot of value in the book, and it holds up very, very well. So I think in terms of an AI savvy operating model, the ideas in Team Topologies, we are using them basically to help guide organizations think through knowledge work in general, not just IT, knowledge work in general, like running a marketing department, running a legal department, like I said, like a doctor's practice. There's a bunch of other places where it's being used. And we're starting now to help organizations think through how they approach AI like this, hence the talk today. And so I think a lot of the ideas from Team Topologies can be used effectively. The very kind of simplistic view of the kind of operating model, if you like, or how work is organized looks like this. We've got lots of different flows, and they're independent and they're fractal. So we can zoom into one area and it looks the same, if you like, as when we zoom out. We're not trying to coordinate things, generally speaking, or at least if we are coordinating things, we're coordinating things in very small groups. We're not trying to coordinate across the entire organization. That feels quite strange. It feels quite strange for lots of people who are used to that. But I think the core principles remain. We would do well to think about socio-technical mirroring. So the ways in which communication happens across the organization has an impact on the kind of architectures that we're likely to build. Is that what we want? If we want to go quickly, if we want to have a very good understanding of how a particular part of the system is operating or is failing, then having good boundaries in place is important for that. So we need to be aware of this thing called Conway's Law. We're not sure exactly how it's going to emerge in the generative AI space, but given that Conway's Law is really fundamentally talking about information flow, I personally don't think much changes, because generative AI, particularly with AI agents, is still basically information flow. It's just speeded up hugely. We need clear ongoing ownership or stewardship of services and systems to be able to diagnose what's going on. That's at least one level. End-to-end responsibility for a service, like we don't want to be designing something and then handing it off. Any kind of handoff like that then is going to make it really difficult if there's a kind of an AI agent involved that's doing one part and then handing it off somewhere else, we're still likely to get a lot of challenges around the execution and diagnosis and so on that we've seen in the IT application industry in the last 15 years. We need to think about flow and reducing extraneous cognitive load. Now, cognitive load in the context of humans, I think, is fairly well understood, or mental load at least. What it means in the context of generative AI, don't know, but it's something maybe to do with the context, the amount of context that agent can reasonably retain whilst still having a high fidelity representation. It's something like that. And I'm kind of interested in that space. I don't have any answers yet, but these principles from Team Topologies feel like they help to steer in the right direction, even if they don't point it to the exact answer. Let's say the agent is doing, the AI agent is doing most of the kind of like writing of code and systems and stuff like that. You've still got a group of people around it who are shaping those guardrails and that input and the context and the business goals. We need multiple different kind of sets of skills around shaping those goals. But we still want to limit the number of people involved to about 8 or 9, because then we get the highest trust effectively with the highest kind of variety of skills and experience around that AI agent. Ultimately, the architecture, kind of, to my mind, remains the same as it is now, which is like an ecosystem of loosely coupled, independently viable services with clear boundaries and ownership aligned to the flow of business value. So we might end up with an ecosystem of loosely coupled, independently viable AI agents. It's the same principles because it's really the same problem, which is trying to represent business intent or organizational intent. We're trying to represent that in code or as an information system. Just because you've got some AI stuff in there, it doesn't really change it. It's speeded up some of the activities hugely. But the nature of the problem, I think, is still the same. Oops. So small, scrappy startups that use generative AI well will be able to out-innovate larger incumbents. What would an effective AI-savvy operating model look like that used AI to reduce time to value for large organizations? Like I said before, I think we know it already. It's empower teams, it's no handoffs, it's ongoing stewardship, clear boundaries, and active knowledge diffusion across the organization to help people learn quickly about different techniques, help even AI agents learn somehow about different options, whatever. There's lots of detail which is clearly missing because no one knows this stuff yet, but that's my take. And where I am is this: I'm suggesting that we should do what it takes to empower teams of humans and AI agents to make decisions quickly, safely, and compliantly, with high fidelity domain knowledge and visibility of like the data sources, the results, and then the agency to address any problems that have been caused by their decisions effectively. It's basically the same ask as it was with human beings. If you take the word AI agents out of there, that operating model is the operating model that works really, really well for teams of humans. All we're doing effectively is then introducing AI agents into that mix too. Yes, the humans will do different things. They might not be writing Python, but they'll still be involved in shaping that kind of service. And the patterns in Team Topologies help us to think this through. Doesn't have the full picture, absolutely. I mean, that's possibly my next book in this space. But that's how I've come to see things, by using some of the principles from my book, and listening to a whole lot of other people, including many of the people who are in the session today and next week and so on, to think through the dynamics in this space. I'm looking forward to the discussion. So if you're interested, let's work together. But let's have a conversation anyway. You'll find me on LinkedIn. I'm looking forward to the chat.
All right, great. Thank you, Matthew. Maybe I'll start with the first question here. We got about 7 minutes, and it's one of your last slides. Architecture for fast flow resembles an ecosystem of loosely coupled, independently viable services. So if we look at last 20 years or so, we can a lot of times pinpoint to organizational architecture or org design, and usually that's decided by the executives in organization. So with AI and everything that you've shared with us today, it seems that's still a bottleneck in a sense for many organizations if leaders don't understand or acknowledge that that architecture, like you described it, needs to be loosely coupled and independently viable, like services. What do you think? In what ways can AI help maybe these leaders design for this type of architecture? Because obviously, at least by my perspective, many organizations are not architected for this type of.
It's a yeah, yeah. I'd agree with you because it's relatively new, right? So it's and the execs who are in place right now have come from MBAs and business management schools from the late 20th century and into the 21st century. So that was full of like kind of Taylorist style management, maximize resources, all of that kind of stuff, which works fine if you're works fine enough if you're running a physical manufacturing plant, but it doesn't really work if you're dealing with knowledge work and trying to navigate unknown situations. But I do see that changing. There are organisations that are really shifting. There's the very public example of Bayer, which is doing a big shift towards way more empowered teams and ways of working. That's led by the CEO. And so I just before the conference today, I was talking to a CIO in a company in Belgium, and he's got the mandate from the rest of the exec team to do a substantial change to how that organization works along the lines of Team Topologies, inspired by domain-driven design and a bunch of other things. And this I think there's momentum behind this, a shift towards more flow-based and more empowered teams and groups of teams in organizations. But it's like turning a container ship around, right? It's going to take a long time. But the results are quite clear. Like the results, like if we rethink how we do work, we can significantly reduce the dependencies. We stop spending money on just having people waiting on other people. If you look in some organizations, then they're spending millions and millions and millions every year having individuals and teams just waiting on other individuals and teams in the organization. And that money is there to be unlocked to spend on something more effective.
Yeah. Maybe
How,
follow up to that. Like a lot of times, yourself, others, myself, as a consultant coach, you come in and you're providing your advice, or if you're coaching, trying to guide the leaders. But what do you think in context of AI, and how could AI contextualize or visualize, even like going into like, value stream mapping and helping organizations understand the current state and where they are and move
yep.
type of architecture. What are your thoughts on that? Like using AI to help design and redesign and constantly evolve the architecture.
So it's a very good question, and we can promise to people on the call that this wasn't a planted question. Well, we're actually working with two or three software startups in this space. There's one which is very, very cool, which is called Team OS. I'll put the link in the chat. So, like disclosure, I actually invested in this organization in this company because I think it's essential that we have a tool like this in available. There are a couple of other tools that are starting to appear on the market now, but this particular tool, like TeamOS, will actually use various signals from across the organization, like Slack and Teams and Jira and ServiceNow and a bunch of other things like this, I think, and pick out details of the communication that's going on and use that as signals to say, hey, it looks like there's a blocking activity here, or it looks like this team has got way more requests into it than it can really handle. And providing then effectively management and at exec level visibility of where flow is blocked and where we can reshape the team boundaries and a bunch of other things like this. So it was the first tool. Well, it's one of a new breed of tool effectively that's coming out to help with that. But there's other approaches too. Like we're working with another tool, another startup, which is kind of cool, where they're using conversation. So record a conversation and then use AI to extract to do like semantic analysis on it and extracting what's the word? The words escape me. Like the emotional aspect of it, basically extract that and then present that back up to them. Clearly, like anonymized, right? But like present that back up to the execs and say, look, there's like a significant portion of the workforce that is really angry about this thing here, and this is a particular problem. So there's some interesting use of tools to help like switched on organizations like do move to a better place. Clearly, these tools can be used like for negative reasons too. So like we need to be very careful in terms of the safety and anonymization and so on and so on.
Yeah.
But yeah, we're working with a couple of vendors in this space, and it's really interesting to see what's coming out.